Thank you. Nice to see everyone. Let me know if I'm not loud enough. I'll be louder. So here's my talk about Intro to Go. I hope that there are people here who are either thinking about learning to Go or beginning to learn to Go. If you are using Go at work and you're super professional, then I hope you get some more material to get your coworkers or the company more excited about Go using this information. So for me, Go started with me just being frustrated with JavaScript for a while. Like I've worked with JavaScript for a couple of years, and then I just needed something else, like a mental challenge to kind of so something different, just so have a kind of a mental like a hobby where I can forget about work and just focus on programming. And today we're going to talk about Go in general, what kind of language it is, why would people want to learn Go, some projects that are popular written in Go that we can check out, a bit on syntax. So I'll just go through some slides of code, and then in the end there are a couple of surprises, but they're like not scary surprises, so it's fine. So a bit about Go. It was created at Google, released as open source software in 2009. So this November, I believe, Go celebrated its 9th birthday. Created by, I'm not going to butcher the names, but one of them is Rob Pike, so it's easy to pronounce. The people who created Go also worked on such technologies as C, B, Unix, Unicode, and you see the influence of that. For Rob Pike, it's also CSP. You'll see the influence of all of those technologies kind of coming together in Go. So the values are: it's thoughtful, simple, efficient, reliable, productive, and friendly. And to me, writing Go sometimes feels like you're writing haiku. It's really nice. So this is probably illegible to most of you, but I took this photo today. It's a photo from the book, so that's why it's so badly rendered. And it shows the family tree of Go, how, like, basically the influences of other languages as they culminated in creation of Go in 2007, I think, and 2009 it was released as open source. So there's some C influence, some CSP. So I think it's communicating sequential processes or something. So basically it's the base of the Go concurrency, and some Pascal stuff that got, so that is mostly dealing with packages, the way packages are structured, and some other things possibly, but that's what I remember from the book. So these are Go, I would say, main characteristics. It's modern, general purpose, strongly typed, compiled. It has automatic garbage collection, so it's a bit, it's slower than C++, C++ or C, but it has garbage collection, so that kind of makes up for a lot of that. Concurrency is a core language feature. There's a unique approach to error handling that we will see in some code examples. So there are no classes. There are structs and interfaces instead. We're going to see examples of structs, but not interfaces. And it's simple and consistent. So why learn Go? Don't look at the end of it. At the end of it is just December. So you can see this is also December. People just relax. So this is December 2018. This is December, and this is January. It's not enough data yet, but it's going up, you know? It's going up, I promise. So currently, this is actually the only slide I kept from last year. I did this presentation in June, so I don't think the new one is available. Maybe it is, but Go is one of, like, 9th out of the 15 most popular languages, and that's by pull requests. And that's the least exciting slide about the stats. I like this stats more. So this is most loved, and this is Stack Overflow's 2018 statistics. So Go is right there, number 5. Rust gets a little love, apparently. The most wanted, so this is by employers, right? So that kind of appeals to a lot of us. Number 3. This is HackerRank, so apparently 38% of respondents want to learn Go next. So beware of those people that might steal your jobs. Just kidding. So JetBrains, they've also done their survey, and this is one of the key takeaways, that the most promising programming language is Go. And there's some also positive stats about Go there as well if you want to check out the full. And you can find all of those stats mostly on the official Go blog, and that's one of the latest blog posts about Go turning 9 years old, and there's a lot of stats there. So these are the companies using Go. You can see the Hootsuite with a smile. So, and also on the bottom you can see the official Go repository. You can see that there is a huge list of all the companies that use Go. So if you want to get your company in there as well, you can do a pull request, I guess. The first 4 companies I took there are Canadian on the second, like the right-hand side. There's no surprises, I guess. There was Apple on this slide before, but I Googled that, like, I don't know if they actually use Go. Might be a lie. So while learn Go, it's super fast. Concurrency already mentioned, reach standard library. And because Moore's law is failing and processors are not getting their frequency up and up and up anymore, so we're just going to have more cores, and Go has a lot of resources to kind of utilize these cores more efficiently than some other languages. So that's nice. Developers love it, and that's why we're here. Rapidly gaining popularity, and the documentation is amazing. Also, it supports Unicode by default. It's cross-platform, so you can be on a Mac and compile to Linux, and also whatever you're using, it compiles to that OS, unless it's like OpenBSD or something. Maybe BSD too, see? I might be wrong on that. So Go empowers creation of huge things like Docker, Kubernetes, I hope I pronounced it correctly, Ethereum, and some companies go from 30 servers to 2, and I've heard 2 stories today actually of some companies going from like 10 servers to 1 and things like that. So it definitely helps, and that's maybe one uncommon way to sell your company on it is just through basic budgeting. Let's see, so project to check out. You can check out this, gobot.io for IoT stuff. There is Hugo, which most of us know now because it's become super popular. It kind of alongside with Gatsby.js. It's a static site generator, super popular. It's nice. I've used it before, and I've had a good experience. Go Buffalo, think of it as like, it's a stretch, but like Rails for Go. It's an ecosystem where you can get things running fast. So Go Ethereum, judging by the name, it's also built in Go, but it is. So I think it's like 40,000+ stars on GitHub. Kubernetes, already mentioned. GoKit is a common library to use for microservices. Also can be done in Go. So a lot of things can be done in Go. Sometimes it's things that you don't think about. But sometimes, for example, I've recently found out, so like on Linux there is a package manager called Yay, also written in Go, and it's become super popular in like Arch/Manjaro architecture. So let's go to the syntax, and this is, I guess, more exciting part of the presentation, at least for me. I like syntax. So there's no semicolons, and that's just talking to the people who come from scripting languages like JavaScript. There's a lot of people, and I think it's one of the not problems, but some things that deter people from learning Go is that there are not enough beginner level resources, and there's not enough resources for, that's my personal opinion, for people who are self-taught and do not have a computer science background. So some of this stuff can be intimidating, but once you get through it, it's not that difficult. It's just the way we present the information. We could do it better by providing more beginner level resources. So that's kind of one of the reasons I would like to do this presentation, and maybe it'll help some people. So everything that you write in Go will go through the Go FMT tool. If you're nice, it will. Basically, it's rules and certain decisions that have been made about how Go should be written, how Go should be structured, and I think I've read somewhere, maybe Rob Pike who said it, but nobody likes the Go FMT tool, but when you're on the other side of the code, like you're not writing this code, but you're reading someone else's code, you appreciate Go FMT a lot. you can only use, and these are just like random things, but you can only use double quotes for strings, not single quotes. It kind of catches you when you are moving from like JavaScript to Go, and no brackets for if-else statements and loops, and we'll go into that. So anything named with a capital letter is exported from your package, so that's the way to manage exports. And unused variables and packages are not allowed. Your code won't compile, or if you're using something like Go imports, it'll automatically take out the imports for you or put them back in, just so there's no overtime, as multiple people might be coming in to work on the code. Sometimes in certain other languages, people are afraid to take stuff out because it might break things. And here, you don't have to think about it. It's done for you. So, and GoDoc is a great way to explore the documentation, and it kind of coincides with the Go FMT tool, because if you follow the guidelines provided there, you'll be able to create documentation for your code just using the GoDoc command, and you can probably observe it on this website as well. So the keywords, there's only 25 keywords in Go, so it's a relatively small language, so to say. And here are some types that are available. These are just primitive types. So the numeric types are in this screenshot that I took, and there's also a string and a bool available for us. So let's go into the code itself. So this is the basic hello world written in Go. You see on top, there's package main, and that's how we declare the package name of where we're running it. And if it's an executable, it's always named main. And if it's something else, like let's say, I don't know, your amazing library called lib, it would be package lib. And then some other main would import your package and use it. Then we import FMT, which is used to print things out, and just use that function to print it out. So it's pretty simple. The function func main is what gets run when you execute it. And that's the main thread. We'll talk about it when we get to the Go routines. So this is the way you declare variables. Pretty simple. The second example over there, you can declare multiple variables in one line. Then this slide is a bit more interesting, because here we can talk about the zero values. So in Go, if you declare a variable like that one on top called int, it will not be undefined or null or anything. It will be the zero value of that type. In case of int, it's a 0. In case of a string, it's an empty string. In case of a boolean, it's false. Is it false? It's false. I bet it's false. F short, and that's in the middle there. We're declaring a variable f with the short declaration. That's the most commonly used one in Go. You'll see it in other examples. And then you can do const as well. So loops, there's only one type of loop, not one type, but one loop construct, like one keyword to use is called for, and you can make every type of loop just with that. So on top you kind of see the while loop, on the bottom you see the for loop, the for loop, and this is the infinite loop, and we can break out of it using the break keyword. So if-else statement is pretty easy, it's the usual one, but you have to remember not to put the brackets if you're coming from JavaScript. Switch statement. So let me compare it to JavaScript again. Sorry to bring it up all the time. But in Go, it's different. So in JavaScript, it falls through automatically, and you have to break that behavior. In Go, it's the opposite. So in Go, you have to be explicit about the fall through of the cases of switch. And I think that's the best way. Just less typing. Switch by type is also available. So in this case, we're switching by the type of the variable that's provided, and that is very useful in some cases where we might receive a string or an int, and we just want to deal with whatever comes in. Pointers. So pointers is also a new idea for someone who's coming from a JavaScript world, or like web development world in general, and haven't worked with C or been like learning C in school and other languages of that sort. So a pointer, as I understand it, is just an address in memory where the value of a certain type is residing. In this case, we have a struct. So we'll talk about structs a bit later, but I think of it as a collection of keys that have a certain type. And then it's almost like a class in other languages, but without the, the overhead, the mental overhead that comes with it. So we can just create more of those structs, or like an instance of it, like we're doing with a Peter pointer, and we're getting an address of that value. So we create it on the fly, we get the address, and it's stored. So when we print it out, we get the value there, but if we print out the address, there it is, basically. Errors. So errors in Go are a bit different than they are in other languages, in a way that, as I understand it, Go thinks of errors as a part of like the life cycle of the program. Errors are something that is expected to happen as opposed to being an exception. And that might change in future versions of Go. Who knows how they're going to remake it, but currently, in this example, it's part of the script, just like a sample script that tries to download an image, and then it creates a file, and essentially later on it would save the content in there. And it expects that an error might happen when we're trying to get something from the server. And if it does, we're going to handle it. And we also can see the defer statement that's, I think, kind of unique to Go. And mostly it's just a syntactic sugar that instead of putting the body close on the very bottom of the function, we can put it right here and forget about it. It will be run in the end when everything else in this function has finished running. Just as a way to visually understand what refers to what and not to kind of lose track of things if your function ever gets bigger, as functions do. So these are just simple examples of the way the syntax for functions works. You declare a function, you give it whatever parameter. If there's a parameter, you have to specify its type. And sometimes the function would return something, usually it would, and that has a type too. You can also use named returns, and in that sense, it could be named, like, let's say on the bottom, it would be named sum int instead of just int. You could do return and not name the sum in there, but it's definitely kind of frowned upon, so you would still write a return sum. So I don't know. I don't use that as much. Arrays. So arrays in languages of the web is a bit different than they are in Go. And what we think of arrays, let's say in JavaScript or some other languages, is slices in Go, and we'll get to them. But in this case, arrays are different in one sense that when you create it, you have to specify the number of elements in it so that the compiler or the runtime can efficiently kind of assign memory to it and kind of forget about it. It knows its boundaries. In this case, var array is it's an array of 3 integers, and the 3 integers is the type. So it's not just an array of integers that's the type. The 3 is actually part of that type we're declaring. And when we're declaring b, we also initialize it right away to 1, 2, 3, 4, 5. Then length this is how you access length of the array. Now slices are a bit more exciting because we don't have to worry about their size as much. It's all done for us in background. So let's say you had and slices also, they're kind of a pointer. So essentially, the array, it exists somewhere. So in our B, in the slice B, there is an array, physical array that is created, not physical, maybe electrical, that this slice points to. So if it needs to resize, if we ever get to, let's say, 5 elements, Go in the background will create a new array, and it'll be a capacity of 8 elements, and it'll put the 5 in there. But we don't have to worry about it. So slices are generally used much more widely, I would say. And that's how you append and copy. Sorry, I kind of went fast there. Append and copy. So maps are just hash tables. This is how you get something from a map, how you set something in a map, and how you delete stuff out of it. And also, you can see a map is a string of strings to int. Also, the behavior of Go giving things initial values kind of could be detrimental to us in this case. So we could try to get something that's, let's say we're trying to get a person that's not in this map. We would get a 0 value of it, so we would get a 0. And how do we check if anything is actually in there, or if it's just a value of 0, but let's say that person exists? We can do it with a special structure with multiple returns. And the first one is the value, and the second is OK. So if you check if OK, it means if something is actually in the map, it just has a 0 value. Or it might have another value. Just if it's there, do something with it. So that's how it kind of deals with that situation. So here's structs again, and that's how we define a struct. And then on the bottom, we create 2 structs. And notice that the comma, trailing comma on the bottom is not optional. You have to put it. And I love that part. For some reason, it is just easier to paste more stuff on the bottom if you need. There we go. So this is how you would do something resembling object orientation in Go. So this is a method that will run on our, sorry, it's kind of on different slides, but this is the pet struct. Remember it and forget it. So this sayName has a method receiver that kind of assigns this method to be available on our struct type. And that's why on the bottom we can do mycat.sayName, and it'll print its own name. And we're using a pointer there because in Go also you have to remember when you're working with functions, whenever a function is run, at least that's how I've learned it, it's a copy by value. So it passes, in this case, it copies the address in memory, but if I were to not use a pointer, it would copy the whole pet and put it in there and use it. So and any method that would that you expect to modify the original value would have to use a pointer to it as opposed to just being a value, because it'll just create another one that will have some other characteristic and it won't do what you expect it to do. And in that sense, it's nice because when you're dealing with huge stuff like the HTTP package and you're creating this whole huge struct that has a lot of methods in it, you don't want to be copying it every time a function is run. So that's why certain things are pointers. So Go routines we'll just cover quickly. Go routine is what makes Go great. One of the things that makes it amazing because of its simplicity of usage. Like it's definitely not easy to reason about originally, but it's easy to write it. So in this sense, it's easy to use the syntax of just Go, func, whatever, and that will create another thread or another Go routine that will run on its own without the main function having to do anything with that. But the main function, if let's say we spawned this in the main function, and then main function, it doesn't care about any child Go routines that it has, and it just runs when it's done, it's over. So you have to make it so that it will wait somehow. And some ways to make it wait, this is one of the ways. So I wish I had a mouse. Oh, I have a mouse. Ah, so stupid. Sorry. So I don't know if you actually can see it though. So this is the, oh no. This is the place where it stops and it waits. So here we're creating a channel. How are we on a channel? Oh yeah, that's because I went there. Sorry, I was supposed to say this is channels. And then we're creating a channel with a special keyword called make, and that's how also you create a map as well. Initialize it to a certain value to be able to use it. Then we run or start a Go routine right there, and all it does, and it sends a message back to the channel called messages, and this part won't do anything until this has returned. So it kind of makes the main wait for it, and then it's being printed, and then we're done. some helpful structures that Go provides. I don't know what to call those, but it's just nice to use. So the range keyword allows you to do some sort of a for each, I guess, or like a map over like a bunch of different types of collections, and it has it's implemented for those types right away for us. So we just use that. And then on the bottom, you can see multiple returns from a function being implemented that we mentioned before, but we didn't kind of have an example of. So this is, I don't know what to call this. It's like sort of string substitution, interpolation in a way, right? And I think this comes from C potentially, I don't know. But the thing is, we defined a certain template of where the value of the next variable that we provided will be thrown, and based on the print verb, like the percentage sign V is a print verb. So in case of some different types, we could do some different print verbs, and it's just very convenient to use. In this case, we would also probably add a new line to it, I bet. So this, all that follows this is from the previous presentation, where I don't think we're going to do it because it's not a workshop, but there's some stuff that we I love that smiley face. Let's go. So these are the exercises. If you're interested, this presentation will be available afterwards, and you can go through those if you want, if you're just getting into Go. If you already work with Go, good for you. Example snippets, and available there, and next steps. So this is a book you would probably want to get to read about Go more. I found it to be one of the best, and this one as well. And some next steps. Basically, what I would really recommend for somebody just starting to learn to Go is to check out, on Udemy, there are courses one course by Stephen Grider called The Go Developer something. You'll find it. It's Grider, so it's easy to find on Udemy. The other course is by Todd McLeod, and that's how I learned the basics originally. And these are rated highest, so you probably have an easy time finding them. Sorry for not including them here. And also, I want to mention Exercism. It's very nice in the sense that, and it's not only for Go, it's for any language. What's great about it is that you have access to great mentors so they have, let's say, 120 exercises available for Go, and 18 of them are the main track. So for each of the main track exercises, you will receive feedback by mentors, and you'll go through iterations of those exercises until it's fully done, and then they'll allow you to continue. And in that sense, you get free mentorship. It's amazing. They don't have that for the other 90 exercises, but there's not so many people who work for free, you know. So it's a great opportunity anyway. Tour of Go, definitely do that. And anything by John Calhoun, I can probably just show you his stuff. He has amazing, so he's the author of the Gophercizes, and he has 2 courses. So if you're interested in learning about testing in Go, he has a, not this John Calhoun. Probably this one. Imagine if years ago he was working on Go already. So Go courses, he has test with Go, web development with Go. These are a bit pricey, but there's so much material and it's very good quality. I think he worked for Google at some point and then he decided to go solo, but his stuff is great. And that's it from me. Thank you so much. Hope it was helpful. That's it.